சுப்பிரமணியன் சாருக்காக ஆபீஸ்ல வாங்கணும் அவர் வேண்டாம் சரி
Ananya ma'am, shall we start?
Hello. Yes, Vimalji. I think we can start. People are joining. We have 51 participants as of now. We are also live on YouTube. Yes, Vimalji, are you able to hear me? Hello?
Yes, ma'am.
Yes. Yes,
ma'am.
Good afternoon, everyone. Welcome to the program. So I think Mr. Raj Ganeshan is logging in, and I think he is logged in with the mobile, and I think logging in with the laptop and bringing the presentation up. So Mr. Ganeshan, are you ready? Okay. So
hi, I'll be getting connect with my laptop in another 5 to 10 minutes.
okay. Okay, Ganesh, please connect. So in the meantime, do we have any questions on the solar energy side from our morning discussion or any other discussion? Do we have any other questions? Kannan sir, thank you. Thank you, Kannan sir. So can I know how many institution participants participated here, either in your institution, how many of the colleges have solar power plant installed? So whichever participants college have installed solar power plant, can you please type yes here? So we just understand how many institutions have adopted solar energy. In the meantime, and the Ganeshan is getting his laptop ready. Maybe if any of your institution have solar rooftop power plant, you can put yes in the chat box. No colleges have a solar rooftop installed. Oh. If any of your colleges have installed solar power plant, can you put yes? Rathinam Technical Campus have solar power plant. Rajashankar sir, thank you sir, thank you. Ashok Kumar sir have a question. Anybody else have a solar power plant installed? Ashok Kumar sir, I will address your question, sir. In a minute, I will address your question. Let me just wait and see if anybody else, any other colleges have installed solar rooftop in their campus. Muhammad Haris sir have mentioned Aditya Institute of Technology. That's good. So Tyagaraja College of Engineering have Vinod sir, Aditya Institute. Fantastic. That's good. Good. So 4 institution. Any other institutions have installed solar power plant? Christ the King Polytechnic, Ramkumar sir. Thank you, sir. Ashok Kumar sir have a question on how prior site selection studies have given effective performance in solar plants. Sir, site selection is very important as far as solar power plant is concerned. And this is important first and foremost for the generation. So we need to find a suitable site with shadow-free space available and proper structural structural capacity to add the solar panel in that. If it is a rooftop power plant, in that structure, and if it is a utility scale power plant, the site should be such that it has a nearby substation to transmit power which is being generated So I think prior site selection studies is the most important part of solar power plant designing stage. And I think nobody can deny the importance of it. And typically, the studies are, I would say, 90% accurate on the performance. If you use a proper software and proper study, your simulation is nearly 90% accurate when compared to the real-time performance. It is only 90% I'm saying because in India we have a lot of other disturbances such as system shutdown, like EB shutdown, maintenance shutdown. So all those things are there. So keeping it that in mind, that's why I'm just saying 90% effective with our predictions. So Vignesh Kumar sir mentioned KPR Institute of Engineering and Technology. That's good. Right. Any other questions? Yes, Velumani sir. So Kumar sir, I think this is a very, very important question on how solar power forecasting support the load dispatch center. Sir, currently all the power plant has to give the predictions for a 15 minutes slots of what they're expecting, and there is only a percentage of variation is allowed, plus or minus. If the variation goes beyond a particular point, then the producer will be penalized, or sometimes even the power may not be taken in if they don't have the available requirement for that, because solar power is depending on weather. Typically always the first priority is given for that, but however, in spite of that, load dispatch center should know what will be the power which they can expect on any given point of time, which can be generated, so that they can give command to switch off and switch on other standby power plants based on that. But solar and all is like from the order of the government, it should be the priority power which should be purchased, and typically you need to keep updating expected power production in the load dispatch centers database for 15 minutes slots. I think 1 week before itself you need to add it, and then you need to you can keep changing it until a day before or something like that. So power forecasting is a very, very important tool, especially when the size of the plant gets bigger and bigger. Then it becomes more important to have this system in place to do that. Thank you, Ashok sir. Right. Kumanan, do we have Mr. Ganeshan back online? Mr. Ganesh, if you're logged in, do let us know so that you can start the session.
Yeah, 2 minutes.
Yes.
Hello.
Kumanan, can you please kindly introduce Mr. Ganeshan?
Yeah, sure, sir. So Good afternoon, everyone. So before inviting our speaker for the afternoon session, a small introduction about him. Mr. G. Rajaganeshan sir, currently working as Chief Technical Officer, Tamil Nadu Advanced Technical Training Institute, and Director of Technical Operations, Vashu Energy in India Private Limited, Chennai. He holds an electrical engineering degree from Anna University. After graduation, he started his career at BHEL Corporate Research and Development Center as a research associate. Later, moving into the academic sector and then turned to be a solar technocrat. Having a strong knowledge in the field of solar energy, he has a vast experience in the project management, technical operation, capacity building, and human resource development involved in the solar photovoltaic integrations. Please welcome, sir.
Yeah, thanks for the invite. Please accept my laptop login in your Zoom, right?
Yes.
Ananya ma'am, can you please accept Mr. Rajaganeshan's laptop login?
Yes, just done. You should be able to enter right now. Yeah, you can enter the Zoom meeting right now. And I've also allowed screen sharing access.
Yeah, got it. So welcome everybody. Can you hear me?
Yes, Mr. Ganeshan. Yes, we can hear you.
Am I audible?
Yes, Mr. Ganeshan, you're audible.
All right. So I welcome one and all, and I thank Dr. Vimal and Kumanan for organizing this program. And I also invite all the peoples who have been part of this program. And I'm very glad that all the academicians are joined together to participate in this program. I really appreciate your time being spent here. And I hope definitely you will have a good takeaway out of this session. Fine. So I hope you have you've gone through the morning session and you take the significant input from Dr. Vimal, who is also into the solar for a long period. And I have a very good knowledge on the same field. And today's discussion is all about...
Excuse me, Mr. Rajaganeshan ji?
Yes.
Yes. Can I request you to mute the YouTube link in your background? I think that is caused.
YouTube link.
Do you have another mobile or anything logged in, Ganeshan? So that might be the...
No, actually I have signed out of it.
Okay.
I'm in the only one device.
Yeah.
Are you getting any echo here?
No, for me, my end it is fine. Kumanan, is it okay with you? Yeah, it's fine, Ganeshan. Please proceed. Yes.
It's okay only, right? Is it okay? Am I audible clear?
Yes, sir. You are audible, sir.
All right. Fine. So today we're going to see about three topics. One is about the components of PV system, another is the off-grid system design, another is the on-grid system design. So basically, the design is the key and core component of any project management. If you look, a quality of system is maintained in terms of selecting a product, but the reliability of performance, the efficiency of performance is depend on the design what you are selecting. So in that, Mr. Ashok Kumar, still the PPT has not been shared. I'm just briefing about what it is, and the presentation will be started very soon. So design is the key part. To design, engineering, procurement, construction is the three main components of a project. So engineering is doing the design, procurement is buying the right product, and construction is assembling it all together with the right practice and good workmanship. So these are the three essential components of a project, if you talk about it. So now what we are going to see is, what are the main components which is involved, how we are going to connect it together. If it is an on-grid system, how we are going to connect, what are the things which is involved in selecting a site, in arriving the capacity of the plant, in sizing the system for on-grid system without battery, as well as for the off-grid system with battery. Okay, so this is what we are going to see now. So now let's start with the components of system. So let me take the presentations I'm sharing now. Is it visible for you?
Yes, sir, it's visible, sir.
All right. So PV system components, as you know that PV is nothing but photovoltaic. So a PV system will have set of components. So we used to call, there are two things usually denote. What differs the normal plant and the solar plant is two components. So one is solar inverter, another is solar panel. So apart from these two main components, all the other components have been called as BOS. That is called as balance of system. So apart from solar inverter and solar panel, if you eliminate, rest all the products, all the components have been used in the regular electrical power system network. Okay, so the main thing which is differentiating the existing power system to the solar is the two main solar component. So the BOS is the thing which involves a lot of components. So the PV system components can be called as BOS components. Right. So we are going to see about mounting structure, then key balance of system components, then DC cable, AC cables, array junction box, combiner box, then safety and protection device, energy meters, system monitoring, then marking and signages. So this is the contents we are going to discuss. Right. Now coming to the main part, that is the array mounting structure. Before going to talk about array, I just want to brief what is a string, what is an array. Okay, so to explain that, I want to take you to your whiteboard now. So there are two things. One is the string, another is the array. So the main difference between the string and array is, this is the electrical symbol of PV module. And like that, you have, let's say like that, you have 4 modules. When the 4 modules are connected in series, then this connection is called as a series connection. Okay, this series connection is actually creating a loop of PV module. This loop of PV module will give an output of 1 positive and 1 negative. This is called as a string. This is called as a string. So in simple words, string is nothing but the electrical arrangement. String is nothing but the electrical arrangement. Now coming to the array. Array is group of solar panel forms the array. Let's say, so here if you look 1, 2, 3, 4, 5, 6, 7, 8. 8 solar panels. So the technical name of solar panel is PV module, photovoltaic module. So let's take 8 modules are there, which is arranged in a single setup, okay, which is in a single mounting structure. So this setup, the whole setup has been called as array. So in simple words, array is nothing but the mechanical arrangement, the physical arrangement. Okay, how physically it is arranged. If you look, that is array. How electrically it is arranged, if you look, that is string. Okay, so it is independent and irrespective. The number of strings should be equal to number of array. That is not the necessary case. There can be 2 strings in one array, or there can be 2 array for a single string. It depends on how it is connected. Okay, but to have an understanding, string is nothing but how electrically it is connected. Array is nothing but how physically it is arranged. So I hope you are very clear with the word of string and array with respect to PV components. If you have any doubts, please ask me right now to clarify, because this fundamental is going to travel for the design part also, as for either it is an on-grid or off-grid. Are you clear? So you can type it in the chat box also if you are clear. All right. Now, I'm just taking back to the presentation. Now coming to the array mounting structure. Array mounting structure, now you can able to relate what it is. So the mounting structure which is used to place the solar panel to form an array is array mounting structure. Okay. So to select a mounting structure, to design a mounting structure, there are some set of parameters one must have to consider, which includes the thermal aspects, corrosion, wind, then material accumulation on PV array, then mechanical loads on PV structures. So these are the very 5 important aspects of components with respect to the mounting structure. Why? Because in thermal aspects, you need to consider the expansion and contraction of the module during the temperature, I mean in terms of the summer and winter. So you should not tight the panel very tightly with in case if you are using a thin film module, you are making it very tight during the winter. In summer, it will actually expand. If you make such kind of an arrangement in winter, in summer, then in the winter it will get contract because of the metal contraction during the winter. So when the tension of the tight is too high, which leads to the breakage of the glass of a thin film module also. Sometimes it happen in a utility scale also during the summer because of the expansion, because of the high tension developed in the glass surface area, the modules got broken. So those cases is also reported. So that is why you need to have the correct torque level to tight the materials, and also you need to choose the proper material to suit the exact site temperature conditions. Then coming to the next part is the corrosion. Corrosion is very important factor to be considered in terms of the seashore areas or the areas where you have more amount of the suspended particles to get corroded. So when humidity is more or the salty particle is more, or it is near the seashore or near the oil refinery, there are higher chances the corrosion will happen. So in those cases, instead of using the MS mild steel metal, you can go for galvanized material, or you can go for an aluminum, or you can go for a stainless steel according to the budget and the type of strength you want to have there. Then the next third criteria is wind. Wind is one of the main criteria. Why? Because the wind prone zone areas will experience the wind to the maximum of 200 kilometers per hour also, because even Chennai has witnessed 125 kilometer per hour wind speed, and also the Gaja and Varda has given a good lesson to us. But the one thing is, if you adhere to the norms of government and if you maintain the proper safety design in terms of stability of structures as well as the concrete ballast you are putting to create the stability of the system, it definitely make your system to be stable even though there is a turbulence from the wind side. Because from my personal experience since the installation of 2011 onwards, we have faced the Varda and as well as the Gaja Puyal also, but we have never have any impact of wind over our structures wherever we have installed. Why? Because we made an assurance of withstanding and wind speed of 200 kilometers per hour from the backside of the solar panel. The MNRE specification says 180 to 200 kilometer wind speed from the backside of the panel. Even though the wind comes, it should not affect the structure. So that is the main condition. So once if you follow those conditions, then definitely the system will not get any disturbances because of the heavy wind also. Then next comes the material accumulation of PV array. So this is not much applicable for the country like India. Of course, India also in the northern parts, sometimes the snowfalls are there. In those areas, it is very critical to be observed, because during the snowfall, what happens, the entire snow will fall over the surface of the glass area, and it will completely cover the solar panel surface. And not only that, the weight of the coverage, the accumulation material over the surface will have the impact on the glass, because the glass will have the limited level to withstand the weight over it. If the weight of the the material over the glass surface is more, it may create a possibility of getting it break also. So that is also important point. Then finally, the mechanical loads on PV structures. So of course, you have designed the structure to fit all the panels, but you also need to take care that all the weight of the solar panel is also has to be calculated to design the system, because the mounting structure, over the mounting structure, you are going to place a panel. So the average weight of panel ranges from 20 to 22 kg. Okay, 20 to 22 kg is the weight of a panel, depends on the different varieties and wattages. So if you calculate the proper weight of each and every module and how many numbers of module, let's say you are going to use a 10 modules in an array, like 5 into 2 cross matrix, then the 10 panel weight, which is 22 kg into 10, so 220 kg has to be calculated as the payload of the structure. So the structure has to be designed in such a way it has to withstand the area of 20 panels, as well as it should withstand the weight of 220 kg. So both has to be calculated. Then the next parameter is the height of this array. Okay. Then what is the kind of foundation, the civil foundation we are putting in? The 4 parameters are the very important factors to decide the mounting structure things. So these are the different types of mounting structure one can be implemented. So this is the ballastic type with the low height, and this is the damper type with a flat roof level. This is the interlinking type on the flat roof, and this is over the tiles, the brown tiles. This is over the asbestos sheet over the factory, and the main thing is we will be providing the walkway to have the maintenance also. Any large scale systems, maintenance will be the very, very critical and crucial issue. Why? Because anyone can install this plant. That is not a big deal. But who is going to ensure the reliability and performance of the plant is the key of the project. So one should take care of the proper O&M feasibilities and provisions, so that in future the people can able to go and stand on the walkway and they can able to clean the modules on time. So this is very important aspect. Then next, coming to the other key balance of systems. So if you take any plant, the main key components are, first is the PV module. Then next is the cables. Okay, this is the cables. Then the mounting structure, which we have already seen. Then this is the DC-DV box. Okay, this is the fourth component. Then inverter. Then this is the AC-DV box. Then energy meter. Okay, this is 6 and energy meter is 7. So these are the main components. Apart from that, if you see here, then lightning arrestor, then remote monitoring, these are all the additional components. Okay, these are the additional components of it. So now we look into the key balance of components. What are the things which is involved? So first is the DC cable, next is the AC cable. So the DC cable and AC cable is the cables which is interconnecting the entire system. One should use the proper cable for the correct application. You should not use an AC cable for the DC application. You should not use the DC cable for the AC application. Whatever cables you are using, whatever MCB you are using, whatever the the SPDs you are using or MCBs you are using, everything should be rated for the correct thing. For example, if you are using for the AC, if you are using for the DC, DC has a separate fuse. DC has a separate MCB. DC has a separate SPD, surge protection device. DC has a separate cable. Okay. DC has a separate indicator. Everything is different. Okay. You should never use the same thing for this. In case if you are going for an AC side circuit, AC side MCB is different. AC side SPD is different. AC cables are different. AC indicators are different. So you should use the appropriate components. For DC, there is a separate DC component. For AC, there are separate AC components. You should use those kind of right components for the right selection. Okay. So this is the main part, the DC cable and AC cable. The next is the array junction box or combiner box. So this junction box or combiner box is mainly on the DC side. If you see the SLD of a plant, so I can show you right now here in the whiteboard. So you can take as an example. So this is your PV array. This is your PV array. Okay. So from the PV array, the source is sun. When the sunlight falls, it produces the DC power. The DC power will actually comes to the DC-DV box. Okay. This is called as DC distribution box. The DC-DV can be called as a string junction box or can be called as a string combiner box or can be called as a array junction box. Whenever it is referred as a junction box, it means the number of inputs coming into the box and number of outputs going out of the box should be same. Let's say 2 strings coming in, 2 strings going out. So this is the junction box. The combiner box, if you look, 4 strings coming in, but 2 strings going out. So which means it is combining. So then it has been called as a combiner box. Okay. But the generic name of the particular thing is DC-DV, DC distribution box. So it can be a junction box, it can be a combiner box based on the application and capacity of the inverter and the sizing of the strings. So if the capacity of the inverter is more, probably you have to parallel the strings and make it as a one string and bring it together to connect it to the MPPT of the inverter. In such cases, we will combine the strings, more number of strings into less number of strings by means of making the parallel connections. So this 2 will become one and this 2 will come as a one string. Okay. So with respect to the DC-DV, it can be a junction box or combiner box based on the application, whether you want to combine more number of strings into less or you want to just provide the safety. The main ultimate aim of creating or making any DC-DV is to provide the safety. Now you may ask a question like safety means what are the safety are coming inside a box? Okay, because any inverter will have the two sides. One is the DC side, another is the AC side. So that is why inverter is in the center of the system. If you look, inverter is actually here. The main work of inverter is converting DC into AC. Okay, this is inverter. The output of the inverter will go to the ACD. Then the ACDB output will go to an LT panel. In the LT panel, it is been connected to the common bus bar. So it will go to the load also. It will go to the local loads. Or it will go via the net meter, solar net meter to the grids. So this is the general SLD of a plant. Now, if you look together, the DCDB can be a combiner box or a junction box, but as I told, the main functionality of any box in the DCDB or ACDB, the ultimate purpose is to provide the safety. Now, in the next coming slides, we will see what are the major components which is involved in the DB boxes and how it is making the safety. Okay. Primarily, if you look, the components inside the DCDB, these are all fuse, diode, MCB, SPD. SPD is surge protection device. Okay. So these are the four main components. So fuse is the first line of safety, MCB is second line of safety, SPD is third line of safety, diode will provide the fourth line of safety. That to block the reverse flow of current from the inverter to the panel, the diode, reverse blocking diode has been employed. Okay. Similarly, in the AC side, if you look, the main components include AC MCB, AC SPD, then indicators to indicate whether the supply is coming, and also there will be meter, energy meter to record, to show variable parameters including frequency, then phase sequence if it is a 3-phase, then power factor, then voltage, current, power and energy. So all the parameters will be monitored in the MF multifunction meter. Okay. So this is the schematic layout of a plant, of a on-grid system. Okay. So whatever the main thing, if you look, that is a part of on-grid system. Whatever I'm talking about is related to on-grid system. Now coming back. So from the previous slide, you have understood that the main components are inverter, from the PV array to the inverter to the AC LT panel. So this is the main thing. If you look, now we'll talk about the component wise. If you look, the PV array is the first component, then module mounting structure is the second component, then cables are the third components, DCDP box is the fourth component, inverter is the fifth component, ACDB is the sixth component, AC cables are seventh component, then net meter is the eighth component. So these are the major components which is involved. Apart from that, if you look, remote monitoring, Wi-Fi monitoring dongle will be the ninth component. Okay. Now, to bring this cable, there are some set of components involved, which includes the PVC pipe, clamp, screws, and all. Okay. And the next part is DC earthing, AC earthing. Then there is one more thing, is the LA, lightning arrestor. Okay. So this is E1, this is E2, this is E3. At any point, the DC earthing and AC earthing should not be mixed together because the fault current of DC and AC is different. So the E1 has to be separately grounded, E2 has to be separately grounded and lightning arrestor has to be separately grounded. Okay, but definitely lightning arrestor has to be put through an earth flat only, earth GA flat only you have to use. Okay, but for the DCTV and ACTV depends on the capacity of the system. You can use a 10 square mm cable or a 16 square mm cable to divert the fault current to the earth. So you must use the proper earth electrode to discharge the surge or the fault current with chemical bonding. Okay, so chemical bonding is must for solar application. Okay, so this is the main key components from the block diagram point of view. So now coming back to this presentation, then disconnection devices, plugs, sockets, connectors, then lightning protection, earthing arrangement, energy meter, system monitoring, marking and signages, and all these things. Now DC cable. Coming to the DC cable is mainly used to interconnect the PV module to DCDB and from the DCDB to the inverter. Okay, so in the both areas we need the DC cables. Why DC cable is so special is because DC cables are double insulated cable. If you look the cross section of the DC cable, it will be like this. So this is the conductor, this is the first insulation, this is the outer sheet. If you see the side view, it will be like this. So this is the first level of insulation outside, this is second level of insulation inside, and this is your active conductor. So this active conductor also, it's a copper conductor coated with lead silver to prevent the corrosion of the material. So that is why DC cables are so special, and you know that DC is 1.2 times of AC. So all obviously the DC cable should have the 20% more capacity than of carrying the current of an AC supply. Okay, so that is also a very important factor. That is why DC cables are so specially designed, and also DC cables are UV protected, so they are ultraviolet protected. So even though the cable has been in the open atmosphere, it can able to withstand all the climatic condition, as well as it can able to give a better performance, and also it is having a very less EMI interferences losses. So these are the main choice why we need to go for DC cables specifically. Now coming to the tools and accessories for the connection. So this connector is called as MC4 connector. So the 4 denotes the size of the conductor, the type of the connector, the model of the connector. So this is the male connector and this is the female connector. This is the Y connector. This is the branch connector. This is the extender. This is the trunk cable. This is a tree connector, and this is 2 in 1 out parallel. And these are the components for making all the crimping and connections of it. Okay. So these are all the cables. What you are seeing here is only to play the game in the PV module side. Okay. Let's say you are having a 2 PV module. The 2 modules can be connected series or maybe connected in parallel to make 2 in 1 out. These kind of cables are. This is for the male and this is for the female connection. Okay, this is also serving the 2 in 1 out purpose only. This is 3 in 1 out purpose. This is also 3 in 1 out purpose. This is also 3 in 1, but the way where you are going to implement is different. Okay, if the panels are arranged in a portrait way, you can go for this. If your panel is arranged in the landscape way, then you will go for this. It depends on the type or the place where it has been implemented. Now, what you are seeing is the key components which is inside the DCDB box. So what you are seeing now here is the fuse. This is the DC fuse. Okay, so this is the fuse cartridge and this is the DC fuse holder. This is a fuse holder. So input is given here, output is taken out. Okay, so positive is given for the string and the positive output is taken out. Similarly, for if you want to take for the negative also, you can employ one more fuse and you can able to control. And this is what you are seeing is the DC diode. Okay, so this diode is mainly solar DC diode. This is mainly used to allow always the current from the PV module to the inverter, not from the inverter to PV module. Because as you know that the diode is a unidirectional device. It allows the flow of current only in one direction. So it has been designed in such a way the DC-DC box will only take the supply from the array to the inverter, not in the reverse way. So to make that condition, the diode has been implemented. But few people will not use diode as because of the economic point of view, because this itself will increase the cost of 350 rupees in a DB box. So people will usually avoid diode because they think that having an MCB and fuse itself a maximum safety. But I personally prefer having the diode is also having a big meaning of deploying it inside a box. So this is also, this is input and this is output. We can take it out. The SPD is called a surge protection device. So the main purpose of surge protection device is to divert the surge or fall current and to the ground. So what you are seeing is a DC SPD. So in the DC SPD, you can see positive, negative input. The output is potential earth. Okay, there will be only output. This will be given to the earth rod. Okay, it will be given to the earth electrode. This is DC SPD. Okay, what you are seeing now here is the AC single phase SPD. Okay, so here what you are seeing is a line and neutral, which means nothing but the phase and neutral. So again, here it both are interlinked common and it is being grounded to the earth. Okay, this is also here. And here what you are seeing is the AC three-phase, three-wire system SPD. So you can see L1, L2, L3 is nothing but RYB. So here it has been again, earth has been given to the common. Here what you are seeing is the AC three-phase, four-wire system, which includes LLLN, which is nothing but RYB and neutral. Okay, but the output is common. Yes. Okay. So what it denotes is, irrespective whether the fault happens in the positive or positive negative together, or in the phase or neutral or the phase neutral have been short together, the fault will be diverted to the earth. So that is the main objective of having this SPD here. So DC SPD is being used in the DC-DB boxes. All the AC-DB SPD is used for the AC-DB applications. Now what you're seeing is the the components inside a DC-DB box. So what you're seeing is the one in, one out. So basically one string is going in and one string is going out. What you're seeing is a 2 in, 2 out. So basically two sets of, so if you're seeing this is one set, you can see the same similar set of two pairs here. Okay, this is circuit 1 and this is circuit 2. So that is the main thing. So what you are seeing here is, so it has been given here, positive input is coming in, negative input is going in, positive input is actually crossing the fuse. So this is the fuse. After crossing the fuse, it is going to the SPD parallelly. And you can have a MCB also here if you want to have a control of DC switch. So in that case, it is being connected in parallel to that. Okay. Then finally, the output of positive will come here and output of negative will be come out. Okay. So here the main purpose of SPD is to provide the safety for positive and negative. And if at all any problem happens, it will be grounded to the earth. Okay. Similarly, in this case, if you see, this is 2 in, 2 out. So in this case, MCB is there. You can see this is the DC MCB. Okay, this is the DC MCB of string 1. DC MCB of string 2. This is SPD of string 1. This is SPD of string 2. This is fuse of string 2. That is this is the positive fuse. For the negative, they are not using the fuse, but if you want, you can deploy. That is an additional safety. Okay. Here you can see this is the positive fuse of first string 1. Okay. So this all have been put together. So this is the first setup. This is the second setup. Okay. So if you deep look, this is string 1. This is string 2. So in that, this is the input, this is the output. Here, if you look, this is the input. This is the input. This is the output. Okay. So basically two strategies, string 1 and string 2, but both are in the same box. In both the cases, we are not combining anything. We are just providing the safety. That's why both are called as a junction box only. So you can see this is also a DC-DV box with a single string control. You can see. This is a fuse. This is the DC SPD. And earth has been combined. So this is the combiner. What you are seeing here is it's a combiner. So two strings have been given input and two strings, and commonly it is combined together and you can take it out. This is AC-DV box. In the AC-DV, what you are seeing is now you are giving an AC supply. So this is phase, this is neutral. It's been given. So it is parallelly connected to the SPD. Okay. And MCB. Output of the MCB is taken to the connected with the grid, because here, according to the system, the supply from the grid is the input to the PV system. That is why it is being given here. Then the output is going to the system. So this is for a single phase system. This is for three-phase system. In single phase neutral has been given. In three-phase RYB neutral has been given. It has been connected parallelly with the MCB, 4-pole MCB, as well as to the 4-pole SPD. Okay. So these are the main components inside a DV box. Then as I told that array junction box means instead of you calling it as a string, the total set of array, whatever strings which is inside the array. Let's say there is a big array. In that there are 4 strings are there. If 4 strings are coming in the box, okay, then it is going out. In that case, it has been called as array junction box, because the entire box deals with this one table of array. If the array is not been highlighted, if the array is not a big and it's only the string is being controlled, then it has been called as a string junction box or string combiner box. So these are the overcurrent protections, like how we've seen the SPDs. These are the MCBs. The MCB is also rated for DC and AC. For DC applications, you can use the DC MCBs, and the DC MCB will have the range of 12 amps, 20 amps, 16 amps, then 40 amps, 50 amps, up to 62 amps. We have DC MCB. For the AC MCB is also up to 120 amps. We have the AC MCBs. And there are very important points with respect to the disconnection device which is being used according to the CA regulation. One is, first, it must interrupt the active conductor. That is the main condition. And it should be being capable of locked in the open position. That is the second important point. And third is the height from the ground level is minimum 2.44 meter for a isolator or control switch to provide the safety, and also avoid from the the access of devices for the children's and all the other safety. Then all the equipments, whatever we are using, should comply the CEA regulation. CEA is Central Electricity Authority. Then next is the plugs, sockets and connectors. Like whatever the plugs we are using, whatever the MC4 connectors we are using, all should be rated for the DC use. That is very important. And also it should comply the IEC 62548 regulation. Then it should be very tight also, and it should be a locking position, because it should not be plug and play should be there, but once you plug, there should be a lock. So manually, if you press the lock and release the connection, then only it should remove. Okay, that is a very important condition. And subsequent to that, UV resistance is important. Then IP is called as ingress protection. Ingress protection means if the connector has been locked, but it's in the open condition. If suddenly a rain comes, dust is there, and the storms are coming in, there are a lot of atmosphere and a lot of environmental disturbances for a thing which is outside. Okay, the temperature, heat, sun, light, everything is there. So nothing should not impact over the safety of the device. So that is why if the device is designed for handling the IP68, 66 or 68, then definitely the device can able to withstand the external environmental conditions, even if it is open. So these are all the very important thing with respect to selecting the components. Then next is the lighting protection, because lighting protection, any system, any solar plants more than 7 kilowatt of capacity, LA is one of the important criteria, because according to the Tamil Nadu government policy, plants more than 10 kilowatt capacity has to be get approval from CAG, that is the Chief Electrical Inspector General. So to get the CAG approval, the main component one must see is the safety of the system, because safety is ultimately needed. So if you really want to look into the safety of the system, then the main factor is earthing and another factor is lighting arrestor. Okay, so lighting arrestor will be employed on the rooftop area where the array has been arranged, and the zone of protection depends on the type of lighting arrestor and the height of the arrestor we are using. So I suggest in a normal plant, you can use one lighting arrestor to an medium level, which can able to cover the radius of 20-30 meters. If the plant has been more or it is a utility scale, then obviously the height of the lightning spike should also be more, and also the number of lighting arrestor to cover the zone of protection should also be more. So this is also a very important factor. And whatever the lighting arrestor you use, you should comply to the standard of IEC 62305 and also IEC 62305. Then earthing and bonding. So earthing bonding is another important factor, because it's not about connecting panels together, also to provide the safety for that. Okay, since the high voltage DC has been generated in the PV array side, if at all any problem happened, the discharge of the fault current to the earth is also a very important and critical factor. So if you look in that way, that is why all the PV module are interconnected by use of cables or the copper rods. The main intention is to provide the safety and the equipotential bonding across the array installation. Then energy meters. So energy meters are a very important thing, because meters will have the responsibility of recording how much of energy imported, how much of energy exported. As far as solar is concerned, when you go with the replacement of solar net meter, it will look like a normal home conventional meter only, digital meter only. Normally, whatever the meters we are having in our home, we'll have the capacity to record the flow of current, but the direction of flow is not accounted. Either the power coming from the grid or from the plant, it is going back to the grid. According to the normal conventional meter, it is a flow of current, but either it is in the forward direction or reverse direction, it will not account it. That is the problem of the unidirectional meter. So whenever current flow detects, the incremental counter will work 1 plus 1 plus 1. So it will keep on increasing 3, 4 like that. But so the problem is, if you use a normal meter for a solar application, even the meter will record the export as import. Okay, that is why we are going for a bidirectional meter. In the bidirectional meter, the advantage is whatever the forward current, it is calculated in a separate counter. Whatever the reverse current is calculated in a separate counter. So the forward currents are added together will show you the import energy, that is I import. Okay, sorry, E import. Then the second counter will show you the E export, energy exported. So the export is subtracted from the import, and that gives the net energy of consumption. Okay, so this is the concept of net meter. That is why it is called as a bidirectional meter, because it can able to record the import as well as the export both in the same meter if the separate register. Okay, that is the main difference between a normal meter and a bidirectional meter. Then the very important part is the system monitoring. 10 years back down the line, if you look, monitoring of the system will be a biggest challenge. Why? Because you need to buy a separate dongle and a separate monitoring device, which cost you around 50,000-60,000. But nowadays, it become a very integral part of the system. And all the inverters which is coming into the market is having the default option of having a the monitoring dongle with it. And it actually provides an interface between the inverter to the user. Okay. Remotely, it's not necessary you have to be intranet, you have to be in the local. So the Wi-Fi dongle, which has been integrated with the Wi-Fi modem wirelessly, through that you can monitor the performance of the inverter anywhere sitting in the world. Okay, you can see what is the performance in the string level in the DC side, what is the DC power produced, and what is the AC power produced, what is the frequency, what is the voltage current, how much unit is being generated today, what is unit generation happen in this week and what happened in this month, everything you can able to monitor. So this is the very important aspects why monitoring is important. Moreover that if at all any problem arises in the system, you can immediately locate, because the monitoring system will have the option of giving the alerts. If the system is not working, if the string voltage is going abnormally, it will give the alert. So based on that alert, the owner of the plant, the developer of the plant, as well as the O&M person of the plant will get the notification, and they can immediately go and address what is the problem. And also you can see the performance of the plant. No one can, put something in the dark that my plant is performing, or you cannot tell any reason that the plant has been not performing because of sun or because of some other issue, because it will clearly show what is the expected generation of the plant and what is the practical you got out of the output. So system monitoring is very, very important part as a part of component. But then next, if you look, marking and signage is very important, because whenever you install a plant, putting this label on the right place will have a better clarity of the people working there. So that is why in the PV module array area, we'll put live during daylight, because the panels are producing power during the daytime. Then next, coming to the warning symbols, which includes in the dual supply, because when any people comes and working on your distribution box, they should be aware that the only supply is not the grid. There is one more supply which is producing and injecting the power to your local network, that is from the solar. Okay, so that is why dual supply, isolate both normal and solar supply before working on the switchboard. This label has been pasted over your LT panel. Okay, so that is why it has been put, and also the AC isolator sticker, which has been pasted over the ACDV box. PV array isolator, DC isolator switch has been pasted over the DCDV box. And the very important part of the shutdown procedure. If at all any problem happens, one should not blink like what I have to do, how I can make the safety for the system. In such case, a normal man can able to read the shutdown procedure, and I can immediately do the sequence like first, second, third. Okay, so he will go, if you see this sticker, turn off the switch labeled inverter AC isolator switch. So there will be only one switch, that is the MCB, AC MCB in the AC side. So first load has to be disconnected. That's why the guy is going and turning the MCB, AC MCB off. Once the AC MCB put on off, then actually the load current becomes zero. Once the load current becomes zero, then that is the safe time to switch off the DC side, because in DC, the arc quenching will be more when you break the circuit. Okay, so that is why when you disconnect the load, then the load current of the DC side will also be, current of the DC will also be less. And then it will be literally an open circuit condition. In that time, you break the DC and you can remove the fuse. That's how you will make the inverter to be get isolated. So this is the procedure, and these are the main, the significance of having the marking and signages on the system. So now I will show you some set of, the list of preparation of POM components for your understanding. So you can have a look at this Excel sheet. So this is bill of material for 1 kilowatt of our plant for your understanding. The segment is classified on first solar array. In that solar array, what are the components, which includes solar modules, mounting structure, fasteners. In the fasteners, the specification of the fasteners being given. So it is the SS304 material, that is a stainless steel grade. Then M6 is the size of the fasteners to interconnect the PV array. Then concrete pedestal, the size and the grade of the concrete M15 grade is being given. Then module interconnection cable 1.5 square mm is being used. Then crimping lugs, ferrules, to denote the number of, the numbering of the lines. Then nuts and bolts washers, that is a galvanized material with M6 size and SS304. Then cable tie, then earthing wires, size of that, then earth electrode, then DC cable, size of the DC cable is 4 square ohm, NC4 connector, clamp, wooden plug, screws, PVC bend, bows, insulation tape, then PVC pipe. This all is related to the PV array side. Okay. Now coming to the DCDB. DCDB, it includes DCDB box, that is the enclosure, then MC4 box, MC4 connector, then DC diode, then DC MCB, then screws, DC fuse, surge protection device, dendril, DC cable. Coming to the inverter side, which includes inverter, DC connector, AC connector, because you need to connect to the inverter, right, to take the power supply or give the input. Then AC cable, PVC pipe, clamp, screws, wooden plugs, earth wire, Cat6 cables to give the communication between the inverter to the modem if you are using a modem. Or if you are having a dongle, you can connect it and integrate with it wirelessly. Then energy meter, then ACDV box. Then the components of ACDV box include AC MCB, screws, AC fuse, then SPD, AC SPD, then dendril to mount the components, then AC cables, 1.5 square ohm to core, then earth wire, PVC pipe, clamps, wooden plug, screws, and earth electrode to divert the AC earthing. Then bidirectional meter, which includes the net meter, AC cable, an LT panel, MCB, and that's how you prepare the budget for the system. So if you are going to work for the system, if you're going to work for the budget of the plant, then you need to probably address all the components required for the project. And with respect to the quantity, with respect to the, the unit of measurement and the quantity required and the unit price, calculate the total price. After adding all the total price, you can come up with the total figure. Then you can add up what is the transportation charge, what is the loading and unloading charges, what is the installation charges. Then you can add your profit also. Then add the GST components, the tax rate. Then finally the plant cost will be arrived. Okay. So this is the part about the PV system components involved and how to work out the budget also with respect to the components to arrive the quote. So if you have any doubts, you can ask me. So participants can able to can raise your questions if you have anything with respect to the PV system components. So any doubts? Are you clear with this topic? So let me take another 5 minutes time to clarify your thing. Thanks, Mr. Ashok Kumar, for giving the appreciation for clear explanation with figures. And what about others? So you got the holistic picture about how actually the components have been employed. What are the specification of the components? How it has been used in the project. So to have the glimpse of... Yeah, tell me.
Hello. Yeah, good afternoon, sir. This is Dr. Srinivasan from PSU College. So I have one single doubt. That is how to install all those things, and what about the maintenance and warranty that are need to be clarified.
Right now, I'm going to see you the practical site photos from the start to end of a project. That will probably address your doubt. But with respect to the O&M of the plant, for any small scale project, the main part to be done is cleaning of panels. Okay. So cleaning of panel can be done once in a week if it is a very less dust area, or twice in a week if the area is more dust. Okay. So that is the main thing. and you can use your normal water and just clean it with a soft mop or sponge. That will be the best.
Okay, okay, thank you.
Yeah. So, Mr. Ashok Kumar, as you asked that if possible, list the standards governing the PV system, I can very well able to share after this presentation. I can able to share you the all detailed codes, which is almost 120 codes are there, which is involved, which includes the IEC, IAS, BAS, and IE regulations. So you can have that in your free time and have a detailed study about it. So now I'll show you the set of process which is involved in the system. So what you're seeing is the raw site, a rooftop before the installation. So the first part is taking all the array materials to the rooftop and making it, and we are checking whether all the array materials are according to the numbers and quantities and sizes. After all it has been done, then the foundation is marked and it has been patched up, because you should not put over the tile. It should be been connected with the roof only, the roof concrete only. So that is why all this patchwork has been done. So once the patches have been done, then the structure will be raised. Then all the structure work is happening here. So parallelly, the inverter DB, ACDB, DCDB box fixing is also be done parallelly. So you can see here. So this is the DCDB box. This is the ACDB. This is the inverter. So parallelly, you can see all the mounting structure has been raised here. So you can see once before it is getting over, the PV modules have been taken to the top. So once the installation has been done, the next work is cabling. So cabling has already been done. Then we are putting the concrete foundations, because that is the main thing to provide the safety during the wind, because you can see the concrete blocks here. So parallelly, the interconnection of system has been done. So this is cable ducts have been used, and DCDB, ACDB, all the interconnection has been over. So now the PV modules have been get connected, and parallelly you can see all the concrete blocks works is also been getting over. And finally, the lightning arrestor is been done with lightning strip, the GA flat, and all the interconnection is over. So this is the final shape of the system. And this is the setup of the PV array. So finally, what you are seeing is a 10 kilowatt of plant. Okay, so this is the process involved step by step from the start to end. These are the set of process involved in installing a system. So if you have any further doubts, you can ask me. Ms. Vijayalakshmi is asking, what is mean by DC diode? Actually, basically a diode is a DC component only. But in the solar, since the DCDB, ACDB box have been defined, we are calling it as a solar DC diode. Any other doubts? So I'm seeing almost 80 plus participants here, but I'm received only 2 questions. Mr. Ashok Kumar is asking, any intermediate testing needed before the installation? Definitely, all the strings interconnection has been done. Then the string testing will happen. First module level testing will happen. Then string level testing will happen. Then finally the string voltage and string current will be tested. Then only it is connected to the inverter. Similarly, AC side also, from the LT panel in the ground floor to the ACDB to the top floor, The line has been checked, all the terminals have been checked. And not only by using the tester, also with the voltmeter, we'll be checking whether we are getting the proper voltage, proper potential at the output. Once it has been studied, if for example, you have an open circuit voltage of 50 volt in a string in a PV module, and you are connecting 10 panels in series, then probably you need to get almost 500 volt at the output of the string. If you are getting near to that, then it is correct. If you are getting only 200 or 300, somewhere it is wrong. Okay, so that's how you will actually, cross check and understand before connecting it. So any doubts? How the issues from rats and other insects need to be handled? I think as far as the rooftop project is concerned, the issue of rat and other insects is not at all a problem. But as far the ground mount is concerned, yes, of course, one must have to take care of all this stuff. But if the rat has been getting and biting the cable, that is because the cable is not dressed properly. Okay. If the cables are hanging and it is touching the ground, then the higher probability of happening, because the rat will not voluntarily go up to the array and it will bite the cable. Even if it tries to do during the daytime, it will get dead. That's a different subject. But you should not allow the possibility of the rat to bite the cable during the night time. Okay. And of course, since it is a double insulated, it is very difficult for the rat to bite the cable, as because the rat teeth are not that much strong enough to bite the second layer of the cable, because the second layer is very, very strong. Even the rat is much more strong with the strong teeth, then definitely you need to have some kind of an alternate arrangement to prevent the rat's entry into your field. That is the only way. So what about others? Do you have any doubts? So Mr. Vijayalakshmi is asking, for 1 kilowatt of solar power generation by PV, how many panels and strings are needed? Is there any calculation? Yes, definitely we are going to see about that in detail in the coming sessions. Of course, to address your question, 1 kilowatt of solar power plant is nothing but 1000 watts of plant. So 1000 watt can be achieved by different ways, by using 250 watts into 4 numbers of PV module, or 335 into 3 numbers of solar panel. And nowadays, advanced high capacity panels is coming in the market. So even you can put two numbers of 500 watts panel to achieve the 1 kilowatt of power. And since all the MPPT inverters, string inverters, you can connect all the panels in series and give the connection. So if you are having 3 panels, you can connect all 3 panels in series and give that one string to the inverter, to the MPPT, and make it operated. So that is how it has been done. So any other doubt? Thank you. Fine. So before going for the next session, I hope I made sure that all the people are having no doubts on this. However, the presentation will be shared to you for your reference, so you can have the look at it. So now the next thing what you're going to see is a design of on-grid system. So before going for on-grid system, there are some primary understanding about it. So I just want to clarify that before going for the design. So there are 2 systems basically. One is on-grid system and the other is off-grid system. Each system has its own level of applications and its the users. So depend upon the type of requirement or the nature of application of the client, the system is chosen. Okay. If you look on-grid system, the main purpose of on-grid system is to reduce the electricity bill. Okay. To reduce the electricity bill. Okay. Then who is having the day load? So the day load consumers like factories, industries, educational institutions, those are working from morning 8 a.m. to 6 p.m. These people are more, the relevant audience for the on-grid system. Third thing is this doesn't have no battery. There is no battery in the system, so it will not provide backup. Okay, no battery, no backup. Okay, fine. Then the ultimate another point is it only works when grid is available. The system will not work when the grid is not available. Okay, so the condition is on grid. Always the grid should be on and it works with the grid only. When the grid gets off, the system will get isolated. Okay, that is the condition of on-grid system. The main objective of going for any on-grid system is to reduce the electricity bill. That is nothing but sharing the load. Then whoever having the day load consumption, they are the most prominent users for on-grid system. The on-grid system will not provide any battery backup. So no backup, no battery. And the on-grid system works only when grid is available. When the grid is not available, the system will not work. Okay. So this is the main observations and understanding of on-grid system. Now coming to the off-grid system. The off-grid system intention is to provide the uninterrupted power supply. Okay. To provide the uninterrupted power supply, the off-grid system is employed. So whenever the uninterrupted power supply word comes in, which means there is a backup. So the backup is available, which is nothing but battery is there. Okay, battery is available here. Fine. It doesn't restrict that you have to be a day load user or you have to be a night load user. Okay, but you need to mention what is the load and what is the backup hours. This is very, very important because I need my 500 watts of load to be operated for 5 hours. That is your actual requirement. You have to arrive what is the total load and it has to be operated for how many hours. That should be arrived properly before designing or choosing an off-grid system. Because most of the people will sell the off-grid plant, they're telling that it is a 5 kilowatt plant. But doesn't mean that 5 kilowatt plant give backup for 12 hours. It may give for 2 hours also. Okay, so that is completely depends on the load and the number of hours the load has been used under the backup condition. Okay, so that eventually or directly refers to the number of batteries required for the system. Okay, if number of batteries are more, then the backup hours will be more. If number of batteries is less, then the backup hour is less. Okay, so that is the main objective of off-grid system. Then the system works even when the grid is not available. Okay, so this system will work. The system will work all time. Okay, that is the main advantage of off-grid system. So one must have to be very, very clear. If I want to reduce EV bill, then on-grid system. If I want to have a backup, then off-grid system. After asking a reduce bill, then again he asks, I need a backup, then it is not possible in an on-grid system. After thinking that backup is essential component and having a battery, then if the guy is asked, I need to export my excess energy and I want to take the benefit out of it under net metering, it is not possible in off-grid. So net metering is available, yes, for on-grid. For off-grid, net metering is not allowed. Okay. So this is the primary difference between an on-grid system and off-grid system. If you have any doubts with this two understanding, please ask me right now, because if you have anything, please get it clarified with any doubts or any queries. If we move forward to the next design, it doesn't make any sense. That is why I'm insisting more on this. If you have any primary clarification on on-grid and off-grid, get it clear right now. So you can type it in the chat box. Sure. Thank you, Ashok Kumar is telling it's very clear. What about others? I feel only 2-3 people have been much active here. Okay, Mr. Velimuni is also telling it's clear, sir. Thank you, Velimuni. What about others? So if you look probably like what kind of systems that you can able to implement in your institutions as an user. So I probably suggest on-grid will be the best choice to go for as an educational institutions. There are two advantages. One thing is you're a day load user, so probably you can use the maximum amount of energy benefit during the daytime. And subsequently, when there is a holiday in Sunday, or maybe like if you have a summer holiday or maybe a Saturday, Sunday holiday also, whatever the unit has been getting exported to the grid, that has been a credit for you. Okay, so you can adjust it, the monetary benefit you can avail because of the export. So this is the added advantage of having an on-grid system in an educational institution. Of course, off-grid will have a backup, but all the educational institutions for the primary stuff, definitely you already bought a DG set. So having a DG set and again going for a battery backup is doesn't make any financial meaning. So in that case, if you have any computers or any essential component kind of stuff, then you can go for an off-grid. But apart from that, anything if you want, you can go for an on-grid system, which can eventually give a lot of benefits. And make sure the grid is always available. So if you are facing a frequent power cut, if your site is facing frequent power cut, then probably you are not the right user of on-grid. Out of the daytime, 3 to 4 hours, if your plant has been shut down, if your supply has been shut down because of power cut, then you are not the right customer of on-grid. You have to look for a battery backup system. If your place has been having a proper supply all the time, but your problem is only the high electricity bill, then you are the right customer of on-grid. Okay, so this is the main difference between an on-grid and off-grid. So Ashok Kumar is asking, people thought of using C20 battery as they are using for UPS to be added with PV system. Share the demerits of its approach. So to address that, C20 and C10, the C rating has to be addressed first. So C rating is the number of charging cycles required to go for a full charge. Okay. So to have a full charge, a C20 battery needs 20 cycles to be get completed. Okay. For a C10 battery, it gets charged in the 10 cycles itself. So it's nothing but it is actually allowing the more current to get charged. So let us consider the two scenarios, C10 and C20. Okay. I am taking a 100 AH battery. So the C rating, if you divide with the ampere hour, so 100 AH divided by 10. So if you do, 10 amps of current can be comfortably charged. If you and discharge also. If you look at the same 100 AH battery with C20 rating, so it will probably only permit the 5. So it is almost C10 is almost 2 times faster charging than C20. That is why solar application C10 is preferred. Why? Because the solar window, the PSH, what we call it as peak sun hours, is 10 to 3. So 10 a.m. to 3 p.m. The effective sun hours is 5 hours. So whatever the 8 to 10 is surplus, whatever the 3 to 5 is surplus. This 2 plus 2, 4 hours, we are not calculating as a part of generation, because according to the solar curve, for the calculation purpose, 10 to 3 is taken as a PSH. So within this 5 hours, the entire battery has to be charged, which means the rate of fast at which the battery gets charged should be more. That's when the battery gets charging during the short span of time. If you go in that aspect, then if you compare C10 and C20, C10 will be the best for solar application. But for home UPS, why C20 is enough? Because out of 24-hour day, if you are getting a 3 hours power cut, then the battery can slowly charge for the next 21 hours. There is no urgency that you need to charge only within that particular time. Okay, because the grid is available all the time, as because the C20 battery connected with the UPS is getting charged from the existing grid. The grid is always available, going to be available for 21 hours. So that is why C20 battery is being chosen for the economical point of view. But coming to the solar point of view, on the basis of application and the availability only during the 5 hours, then you must choose a battery which should absorb more amount of current in a short span of time. That's how C10 is chosen. So you got the point? Thank you. Any other doubts? If you have any doubts, please ask me. Then we'll go for the design of on-grid and off-grid separately together. So the design is a very, very critical and very important part. So to start with on-grid system design, I personally suggest you to take your calculators, pen and note with you, because we are supposed to do the calculations here for the on-grid and off-grid system design. So please take your calculators, pen and paper. And let's start on the on-grid system design. As you know, the schematic layout of an on-grid system is CCDB, inverter, ACDB, load, net meter, grid. So this is the schematic representation of a on-grid system. Now let me explain how the system works before going for the design, because that is very important. Usually when sun is available, the output coming from the PV array to the DC DB is DC. Then the same DC, after crossing the safety, it is going to the inverter as a DC. After going to the inverter, the DC is converted into AC. Okay. So now the DC is getting converted into AC. So it become an AC now. So this AC is going to the ACDB. From the AC, it is going to the LT panel. Once it reaches LT panel, it has two options. Either it can take a way to go to the load, or it can take a way to go to the grid. That depends on two nature. One is from this point, if there is any local loads, then it will go. If there is no load, then it will get exported to the grid. Okay. If it is coming here, then this condition is called as captive consumption. Imagine a scenario, solar is producing 100 watts. My load is 100 watts, which means the 100 is being utilized here itself. So there is no import. So the import is 0. Okay. The next condition is, I'm having a load of 200 watt. The 100 is being produced by the solar panel. So whatever 100 is being coming here, but still I have a deficit of 100. That 100 is taken from the grid. So here my import is 100 watts. This is called as import condition. Let me take another scenario. So I am having a 200 watts of generation, but my load requirement is only 100. Okay. So what happened is, out of the 200 watt, the load requirement is only 100. So 100 is coming here. The rest surplus 100 will go to the grid. This condition is called as export. Okay. So this meter, net meter, will record how much of import and how much of export. Okay. So this is the functioning of an on-grid system and its metering methods. Now, on what basis, on what principle the on-grid inverter is working? So I have explained you the concept of it, but what is the principle behind how this load is sensing where this power is coming from? Okay, so that I'm going to explain you now. It is very clear that always for the load, not for the load, the energy always flows from higher potential to lower potential. Then wherever the energy generation, the point of generation is near, the potential will be slightly higher. For the grid, the generation is happening more. So usually the on-grid inverter pumps the power into the network slightly higher than the grid potential. Imagine a scenario, the grid voltage is 230 volts. Okay. The inverter first will not directly inject. It will first take the reference of the grid. On the reference, after taking the reference, the inverter understands the voltage is 230 volt. Then it decides, I need to synchronize with that. Okay. During the synchronization, the tolerance should not be more than plus or minus 5%. So the 230 volt, instead of this reference supply 230, it will start injecting us 231 on the same line. So what happened, since for the load, there are two potential supplies. One is 230 volt with the grid side, another is 231 from the solar side. The load will always attract this supply first, because the potential is slightly higher. So whatever the current coming along with this potential is first utilized by this load, and whatever the rest current required will be taken from the grid. This is how the load is getting the priority of utilizing the solar power first, then the grid as the next. Okay, so this is the concept behind the working of on-grid system. And if you are clear with this, let me know. Or if you have any doubts, please ask me. Once you are clear with this, then we move for the design of on-grid system. Punita is asking, sir, in C20, C10, 20 and 10 represents hours. None of that is the charging cycles. Ampere R is the capacity of the battery. C is the rating. That is the charging cycle rating of the battery. So Kannan is saying, Mr. Kannan is saying it's clear. What about others? Is it clear for everyone? If the grid voltage, Ashok Kumar is asking, if the grid voltage is varied in instant, how inverter will reflect? Yes, there is a plus. I mean, like if you see the standard of IEC for an on-grid inverter to be get reflected, so it is plus or minus 10% of its fluctuation from its rated voltage. In simple terms, I can say, if you take 230 volt as the, if you take 230 as your nominal voltage, so it can go up to 180 volt to 254 volt. Okay, so this is the range up to 180 volt to 254 volt. The inverter can try to synchronize. Okay, but if the fluctuation of the grid is more than 5%, then the synchronization will not happen. Okay, the inverter will wait till the fluctuation is get resolved, then only the inverter will synchronize. But within the 5%, if anything is there, let's say if the grid is 230, it will give 231. If it becomes 290, it will give, sorry, if it becomes 229, it will give 230. Like that, it will go. But if the tolerance is more than, if the fluctuation is more than 6%, the inverter definitely isolate. And if the voltage of the system will go below 180 volt or go above 250 volt, the system will not work. So this is the basic understanding about the on-grid system and its working. Now we'll go into the design of system. Is it clear with you? On-grid system. Can you able to see the presentation?
Yes, sir, clear.
Okay, right. So now we are going to the system. So any people who wish to go for solar on-grid system, there are primary criteria. There will be the set of expectation from the client. So one is you should not pay the EB bill. The next is I want to export my excess power. The third thing is I want to generate power for myself and I want to utilize. Okay, but I'm not worried about the export. So these are the basic three objectives of anyone going for solar. Now, before deciding the capacity of the plant, one must have to understand the EB bill of the client. And under the EB bill, what are the parameters one must have to look is the tariff category of the service connection, whether it is coming under domestic category or commercial category or is coming under an educational institution, and 2B1 belongs to the government institution and 2B2 belongs to the private institutions. Then EB unit consumption of the month, and whether he is a single phase customer or a three-phase customer or an LT customer or an HT customer, then what is the EB rate, unit rate at which he is paying to the electricity board. So these are the things we need to understand and arrive from the EB bill. Then to understand from the consumer number, how to understand, how to interpret the consumer number. If you look, the region, first 2 digits denote the region, the next 3 digits denote the section, the next 3 digits denote the distribution, and the next 3 digits or 4 digits denotes the service connection, service number. And the eligible solar plant capacity is, before it was 90%, now it is 100% of the total load. Why I put 90% to differentiate like what was the previous and what is now. So now it has become 100% of the total load. What it really denotes, if you look, if you are having a service connection number and your sanction load is 5 kilowatt, then 5 kilowatt is the maximum plant capacity you can go for. You cannot go more than that. So that is the main thing. So 90% of the total load is not now, it becomes 100% of the total load. So if you have a 10 kilowatt load, you can put a 10 kilowatt system, but not more than that. You cannot put 11. But if you want to put 5, you can put. If you want to put 2 also, you can put, because it is less than your sanction load. Then for the calculation, 5.5 hours we can take for the calculations of PSH. Then generation for a 1 kilowatt of plant per day, we used to consider 4.5 units per kilowatt per day, which means my 1 kilowatt of plant will generate 4.5 units of energy in a day. Okay, so that is what the understanding of this. Then next is the unit and assessment amount tabulation. So if you want to arrive the capacity of the plant, you need to really take the average of the last 10 or 1 year data, because when you see in the winter, the requirement will be less. When you see in the summer, the requirement will be more. You should not design a system by considering the summer requirement or by considering the winter requirement. If you see in the same presentation, in the same slide, you can able to see the lowest consumption of the person is 4753. The highest percent, the consumption is 9976. So it is, you can see almost 40% of the requirement is less during winter and high in the summer. Okay. So what is the solution for this problem? You need to take the average of all. Okay. The average of all units consumed and average of all amounts paid. If you divide this value with, if you divide this with this, then you will get the average cost per unit. So that is what's given here. So calculate 1 year amount of EB bill assessment amount. So take the 1 year EB bill amount, average the EB bill assessment amount and average the unit consumed. If you divide, you will get the unit prices comes around 8.7 rupees per unit. Then this is the average unit consumption for a month. This is a different scenario, how to arrive the plant capacity. So the average unit consumption for a month is for a customer, let's say it is 7141 kilowatt hour. The average consumption for a day, to arrive the consumption for a day, you have to divide by 30. Then you will be getting this much of unit. That is this consumption for a day. As you know that 1 kilowatt of plant will generate approximately 4.5 units in a day. So if you divide this value with 4.5 units, you probably arrive what is the plant capacity with respect to solar I need to put in order to generate 238 units in one day. Okay. So this is how you need to arrive the plant capacity. Then next is the conditions of the plant. One is making the bill zero. The next is the partial import. And third is the complete export. Okay. So this is captive condition with zero export and full utilization. This is half utilization and half export. This is no utilization and full export. Okay. These are three conditions. And when you deal with the customer, probably there will be three set of questions will come. First is how many kilowatt I need to install to make my bill zero. The next is how many percentage we can install for X kilowatt. Let's say if I want to reduce 50% of my bill, how many kilowatts I need to put? This might be the one question. The next question is if I want to put 10 kilowatt out of my requirement, how much percentage of my EB will get reduced? Okay, that is the second approach. So you have to convince the customer in all the three approaches. That's how they will understand like what is the impact of this plant over their savings. Okay, so that is the main thing. All right. So these are the three conditions as we already discussed. One is the import condition, another is the export condition, and third is the captive consumption. So first you can see the panel is producing 100 watt, whereas the load is having 100 watt. So it means the 100 is going to the load. So there is no import, there is no export. So it becomes zero. Okay. The next condition is import condition, which means panel is producing 100 watt.
Hello.
Load is having 200
sir,
watt.
one second, sir. Sorry for interruption, sir. Janaki ma'am, can you please mute yourself? Mute your mic. It's disturbing others. Please mute your mic. Janaki ma'am. So otherwise, Ananya ma'am, can you please mute your Janaki ma'am mic now? Okay, so I think she's not on the line. So you can continue.
Shall I continue?
Yes, you can carry.
So the second condition is import condition, where the panel is 100 watt and the load is 200 watt. So even though the 100 has been given here, still you have a deficit of 100. So in this condition, import is 100, export is 0. The third condition, panel is producing 100, the load is only 50. So here 50 will go here, but still the surplus of 50 is there. So that will go to the grid. Here the export is 50 watts, but import is 0. Okay. So these are the three conditions of an on-grid system. Now, let us talk. I think the voice is not getting resolved. Let me check. Janaki ma'am.
So one second, I'll call her.
So who is the host? Sneha Varsha is the host, right? So Sneha Varsha can able to mute her.
Ms. Neha. Hello, I'm meeting earlier.
Shall I continue?
அப்படி இல்ல நான் கூப்பிட்டு இருக்கேன் நீங்க எதுவும் ஒண்ணுமே ரிப்ளை பண்ணலையே கேட்டேன் சார் நம்ம ஜானகி மைக் வந்து மியூட் பண்ணி விடுங்க ரொம்ப டிஸ்டர்பா இருக்கு சார் இல்ல நான் உங்களுக்கு தான் சார் ஹோஸ்ட் சார் உங்களுக்கு அக்சஸ் இருக்கு அக்சஸ் இல்ல எல்லாரும் உங்கள கூப்பிட்டு இருக்கணும் நீங்க ரிப்ளை பண்ணலையா அவங்க ஜானகி அவங்க கூட மீட்
I think the host can able to do that.
Yes, sir. Yes, we can continue now, sir.
Okay, right.
Our mic is muted.
All right. So now, as far as the design is concerned, let us start doing a design of 5 kilowatt of plant. Okay. So now what we are going to do is we are going to design a 5 kilowatts solar on-grid plant, on-grid power plant. We are going to design now. So to have a basic understanding, the plant capacity 5 kilowatt is actually denoted as 5 kWp. What it means is the watt peak. The plant capacity is actually defined on the PV array capacity. Okay. PV array capacity. If the panel is 5000 watts, then it has been denoted as 5 kWp. Okay. Similarly, you can use an inverter of PV inverter of 5 kilowatt inverter, which means the inverter can able to give the load of 5 kilowatt at the maximum. Okay. Now, if the 5 kilowatt is being decided, the plant capacity, which is nothing but 5000 watts is required, then the available panel ranges you can choose. For our understanding, 200, 250, 300 watts are available. So 250 watts, let's take an example, 250 watts you are choosing. So you can array how many numbers of panel is required. If you use 200 watts panel for the 5000 numbers, if you divide this, then you will get probably 25 numbers of panel is required to build up 5000 watts of 200 watts panel. If you use a 250 watts panel, then you need 20 numbers. If you use 300 watt panel, you need 17 numbers. So when you go for this kind of setup, and when dual strings are coming in or dual MPPT are there, even numbers of panel sizing is required. So in this case, 250 watts panel has been chosen. So you can see here 250 watts panel. So 20 numbers of panel is required. Okay, right. So out of this 20, how we are going to connect is the next question. So as you already told, what is array we have seen, what is string we have seen. So array is how physically it is arranged. String is how electrically it is connected. And open circuit voltage of the panel and the string, then short circuit current of the panel and the string, then maximum system voltage. So, you know, VOC is nothing but the voltage which has been measured in the open circuit condition. Okay, it is applicable for the cell, it is applicable for the module as well as for the string also. Then short circuit current, this is applicable for the cell, module and string also. Then what is the maximum system voltage? So when you keep on connecting the panels in series, usually in series connection, voltage will build up. Okay. So when you keep on connecting, there should be a limit that this is the maximum voltage that I have to restrict. Okay. Usually in the normal system, 1000 volt VDC, 1000 VDC is the limit. In the high capacity system, in the 380 watt and 500 watt panels, 1500 volt is the DC is the maximum DC voltage. So imagine a scenario if the panel is having an VOC of 50 volt, then the maximum VDC is 1000 volt. Then what is the maximum number of panel one can able to connect is, if we divide, then probably 20 numbers of panel you can able to connect. Okay, in series. If you connect 21 panels, then the open circuit voltage will exceed, and if you put it in the circuit, then definitely the cable will burn off, because the maximum permissible voltage on the particular module to the maximum is 1000 volt. So one should not exceed more than that. In a way, in the design, if you look, we will be considering the factor of safety. and we'll be loading only 75, 80% of the system, or maybe 85%. The 50 to 20% is always taken as a cushion or the factor of safety for the future purpose, also for the safety of the system. So, as you're all professors, then you're probably very well aware of this series connection and parallel connection. So you can see 12 volt, 100 watt, 4 amps. The same, when you do a series connection on parallel connection with respect to solar, you should use the same capacity, same specifications of module. Either you want to connect in series or you want to connect in parallel. Okay. In that case, then the 24 volt, if you look 12 volt, 100 watt and 4 amps PV module, if it is connected in series, then the output will be 12 into 12 plus 12, because it is connected in the series, the voltage will build up, become 24 volt. Then 100 power will also add to become 200 watt. Since it is connected in the series connection, the current in the loop remains same, so it will become 4 amps only. That is series. And come to the parallel, it is reverse. So it will become, the voltage is going to be parallel here. So 12 volt, 12 volts, all will be there. Power obviously will add 200 watts. 4 amps will add together to form an 8 amps, as because it is connected in the parallel. Now, the first step of choosing the module. So as we already decided that we are going to use a 250 watt panel. So the 250 watt panel is this one. Now we are going to see what are the specifications of the 250 watt. Okay. What are the specifications of the 250? We are going to see now. Now, the first condition what we need to see is what is the maximum power? 250 watt. Then what is the VMP? What is the IMP? Then what is the VOC? Then what is the ISC? Then VDC, as you already know, 1000 volt. Okay. So these are the main things one must have to look. If you see, the main points is what is the maximum power, what is the VMP, IMP, VOC, ISC. Okay. This, all the 5 factors has to be clearly understood. So if you look for a 250 watts panel, these are the things that you need to note down before starting a design. Okay. So you also can note it down. I hope you have noted. So Bunita is asking, will it vary depends upon PV cell manufacturing company? Yes, of course, it depends on the type of cell, technology of the cell, and the specification of the cell. Okay, some people will be manufacturing 330, some people will be manufacturing 335, and some people VOC will be 48.8 volts, some people VOC will be 45.2. So selecting an, in simple words, you can say selecting an inverter and PV module is like matching a bride and bridegroom. So like how the horoscope is been matched for a wedding, similarly the data sheets of PV module and PV inverter has to be matched properly. Otherwise problem will happen in the future. So now we are checking the data sheet of PV module first. Then subsequently we will see the PV inverter data sheet also. We will be considering few factors and we will check whether those limits are exceeding the limit or within the limit. The main purpose of doing this fact check is the parameter should not exceed that safe limit. Okay, that's why we are checking this factors. And once it is all within the limit, then we will go for the next set of design. Once it is over, then the interconnection happens. That's why the system, that's when the system will become safety for operation. Right. Now we are checking from the module point of view. The maximum system voltage VDC is given as 1000 volt. Okay, how many numbers of panel can be considered in one string? That will be the first question. Okay, to go for it, we must go to the PV module VOC. Okay, for the 250 watt panel, we have seen the VOC is 37.8 volt, but the maximum VDC given is 1000 volt. If you divide the 1000 volt by 37.8, it gives 26.45 numbers of panel can be connected in series in order to not exceed 1000 volt. Okay, in one string. Okay, so we are right 26 numbers of, so the 5 you just eliminate. 26 numbers of 250 watts panel can be connected in one string. This is the first conclusion, but this is not the decision. It's a first conclusion that we are concluding. 250 watt panel, 26 numbers can be connected. We keep this aside. Now coming to the inverter data sheet. For the same 5 kilowatt in plant, I'm going to choose a 5 kilowatt inverter. The 5 kilowatt inverter, the maximum voltage is 600 volt. See, the beauty is the maximum voltage of a PV module is 1000 volt. Because a PV module can be used for a 5 kilowatt plant or a 10 kilowatt plant or even a 10 megawatt plant. That is different. It depends, completely depends on which inverter it is being connected. So it is not only necessary to check with the datasheet of inverter in terms of number of panels can be connected in string. It also depends on the inverter specification too. Okay, so that is why the maximum voltage of inverter is highly needed here. So according to the inverter, it is 600 volt. Okay, so if you look in that aspect, then again the same calculation we are doing for inverter side. So the maximum DC input voltage for an inverter is 600 volt. We are considering 20% as a factor of safety. So we are going to load only 80% of the string. So if that is the case, then 600 into 0.8, if you put 480 volt is the safety point of approach. So in that 480 volt, how many panels can be considered in one string? So that is the input to the inverter. So the maximum DC input voltage is 480 volts. So that is taken here, divided by 37.8. So this is the VOC of the PV module of 250 watts. Okay. If you divide, then the figure is 12.36. So basically 12 numbers of 250 watts panel can be connected in one string comfortably to the inverter. Okay. As we already know, the number of string for the inverter is 2. Here you can see what is given. There are 2 MPPT trackers. So this is first MPPT tracker. This is MPPT 1. This is MPPT 2. So the both MPPT have one positive, negative as inputs. Similarly, this MPPT is also having one positive, negative, one positive answer. So basically, this is string 1, string 2 of MPPT 1. This is string 1, string 2 of MPPT 2. Okay. So total strings is 4. So it is nothing but 2 plus 2. Okay. This 2 belongs to the same MPPT 1. This two strings belong to the same MPPT 2. Okay. Technically speaking, there is 2 strings, two main MPPTs. Under that, string 1, string 2 is there. String 1, string 2 is there. So even you connect in string 1 or string 2, it is both get paralleled inside the MPPT 1. And similarly, wherever you give, it is get paralleled in the inside MPPT. Okay. So this is the understanding. So now we know that 2 strings can be given. In one string, we can able to give the maximum of 12 panels. But how many panels we have? 20 panels. What is the maximum limit of one string is 12. How many strings we can able to give? 2 strings we can give. Now how we are going to divide? We are going to divide as 10 plus 10. So in the first string, we are going to give 10 panels. In the second string, we are going to give the 10 panels. Okay. So that is how it is being decided. So this is the solar panel design. So 20 numbers of solar panel is required for this plant. So we can connect 10 panels in one string. So 10 into 2 will become 20 panels. So we are checking the parameters, whether the voltage is exceeding, the current is exceeding. As we know that 600 volt is the maximum voltage, but if you connect 10 panels in series, then the VOC will not be more than 380 volt. But the maximum voltage is 600 volt for the inverter. So the 380 is less than 600 volt. Yes, we are in the safe. Okay. So that is how you are verifying for the first string and second string. And even if you connect two strings in parallel, for the individual MPPT, it is not going to be more than 9 amps because the short circuit current of the PV module is only 8 amps. Okay. Each is given to the single MPPT. So 8 amps is going for the MPPT 1 and another 8 amps is going for the MPPT 2. Even if it gets combined both together, the current is 17.2 amps. The maximum current the string can be accepted for the inverter is 19 amps. So that is also within the limit. Now the PV module strings is going to be get connected to the inverter. That is our inverter. Before the inverter, the DB box comes in the place. So here, how many strings is required? 2 strings are there. The first string is that is the 376 volt, 8.6. Second string is same. Okay, right. Now, this is the DC-DB box. As you already seen in the component section, first line of production is DC fuse, second is diode, then comes to the DC MCB, and finally it goes to the SPD. This is going to the earth, and this is the output. Okay, this is for the first string. Similarly, the same mirror image for the second string replica is also in the same box. So this is nothing but 2 in, 2 out box. Okay, for this particular design. And this is the ACDB. The ACDB will require the meter, indicator, then AC input, AC MCB, AC SPD, and this is the output. And this goes to the earth. So this is the SLD of the plant. Finally, the plant has been connected like this. So this is the first string. This is the second string. It is all given to the DCDB. So DCDB 2 strings are coming in. This is string 1, string 2. So the inverter will convert the DC to AC, and it is coming to the ACDB. From the ACDB, it is going to the solar generation meter. This is nothing but a normal generation meter to record the number of units generated solely from the inverter. After going to the panel, it is having 2 options. Either it will go to the grid or go to the load. But in this point, it is only the travel of energy. So that is why the SGM is employed here to record the actual energy generated from the inverter. After it comes to the panel, it has 2 options. Either it go to the load or to the grid. That is a different scenario. If it goes to the load, that is the captive. If it is go to the grid, that is the export. Okay. So this is the on-grid system design. If you have any doubts in this, you can very well ask now. Do you have any doubts? VOC, Vijayalakshmi is asking, sir, can you explain VOC 37.8 volt calculation? So VOC is a standard, that is the open circuit voltage of a PV module as per the data sheet. Okay. If you arrive 10 panels, you are going to connect in series connection, then you need to cross check whether if you connecting the panels 10 numbers in series should not exceed the maximum voltage of the string which can able to give as an input to the inverter. Okay. The maximum string voltage the inverter can accept is 600 volt. But the factor of safety, if you consider 80% loading, it is 480 volt. Under the 480 volt, we are loading only 378 volt. So the system is under safe. So that is why we are cross-checking that. So Mr. Ashok Kumar asking, is there any scaling factors need to be considered in selecting inverter? If you overscale the system for the future purpose, it will affect the inverter specific performance also. The specific inverter efficiency will get hit. If you connect a 5 kilowatt array to a 10 kilowatt inverter, the inverter will not have its perfect operation. So you can oversize 30%, you can undersize 10%, 10 to 15%, but not more than that. In a 10 kilowatt inverter, you can load up to 11 kilowatt of PV module or 11.5 kilowatt of PV module. The same 10 kilowatt inverter, you can give minimum of 7 kilowatt of PV array or 7.5 kilowatt of PV array. not less than that and not more than that. So there's the next question. What is the impact of charge controller in the system? As there is no battery in this system, it is an on-grid system. There is no involvement of charge controller. Charge control will be applicable only in the off-grid system, which we are going to see after this session. Any other doubts? So, Mr. Kumanan, are you online? Mr. Kumanan, Mr. Vimal, anybody is there from the organization side? Mr. Kumanan, are you online?
Yes, sir.
Yeah, so I think we can have a break now because we have one more session left.
Okay, sir.
So what is the time of duration we need to give for this break?
It's up to 4:30, sir.
No, I'm asking what is the duration of the break?
So wait a minute, sir.
10 to 15 minutes.
It's a wait a minute, sir. Wait a minute, sir.
All right, so now participants can go for a break for 10 to 15 minutes and just come back and we'll see the off-grid system design subsequently. Hi, welcome back. Mr. Kumanan, shall we start?
Yeah, sir, we can start.
Hello.
Sir?
Yeah, shall we start?
Yes, sir. Please do.
All right. Fine. So now what we are going to see is the continuation of the design. So which is the off-grid system design now. We are going to see. So again, I suggest calculators, pen and note with you. So it's very easy for to note down the important points. So like how an on-grid system is being discussed, now we are going to see the off-grid system. As you know, the main objective of going for any off-grid system is to provide the battery backup. So ultimately, like in on-grid system, how the unit requirement has been calculated and the capacity is arrived. Similarly, in the off-grid system, the load requirement is understood with the backup hours, and that has been calculated for this. So that is the main objective of going for an off-grid system. And one should be very clear about before choosing an off-grid system, because off-grid will never export any excess power to the grid. Off-grid system will only provide the backup. So we must be very, very clear on choosing the system and its objective and its nature. So now we'll start with the off-grid system design. So like how I explained the on-grid, let me explain the off-grid also. So an off-grid system will have the PV array, and the PV array will be connected. The output of the PV array is DC. So it is connected actually to an ECU. The PCU is nothing but a combination of charge controller and inverter. Okay, the PCU is so called as power conditioning unit. Okay, so this PCU is connected bidirectionally with the battery. Okay, this is connected to the battery. This is your PV. And the output of the inverter is actually an AC supply, which is connected to the dedicated loads. It's connected to the dedicated AC loads. And the inverter is having an auxiliary input of AC supply. Okay, grid supply as an additional auxiliary source. So the first priority is for solar. I think mute பண்ணனும்னு நினைக்கிறேன். All right, so now it is mute. So the first priority is for solar panels. So the DC power coming out of solar panel will come to the charge controller, and the main work of charge controller is charge the battery. If the battery is 100% full, okay, then it will divert the DC to inverter to get converted into AC, and it will go to the dedicated load. That is second priority. You may ask a question, when 100% of the DC power is coming to the battery, who will take care of the loads? By that time, if grid is available, this grid will take care of the load. If grid is not available, okay, in case if the grid is not available, then the priority will go for loads. Then whatever the rest power available will come for the battery charge. Okay. So in case the production from solar panel is 200 watts, if load is 200 watts, literally the battery will not get charged. Imagine a scenario of the production is 200 watt and the load is 100 watt, then the 100 watt will be go for the battery charging. Okay, this is how it has been prioritized. Right. So now as for the priority sequence, first priority of solar panels to charge the battery, provided the load is there, it will look into that. Once battery is full, then it will share the power to the AC converter from DC to AC to heat. In case if battery is also 100% full and there is no load, but panel is producing the power, then where this power will go? If you ask the question, in a normal off-grid system, this power is unutilized. The electrons move statically, it will waste its energy, but no work will happen. It will not charge the battery, it will not give to the load. The power is actually unutilized in a normal off-grid system. Okay. But in an hybrid system, where it is a combination of on-grid and off-grid, okay, that is actually not permitted in Tamil Nadu. So that is why we are not focused on it. But technically, an hybrid system is combination of both. Okay, it can charge the battery, it can give the power to the dedicated loads. If battery is also fully charged, load is also not there, by that time the excess energy will go to the grid as usual as what happened in an on-grid system. Okay, this is the difference of hybrid inverter. Now coming to the off-grid power plant, the priority is the solar panel will charge the battery. Once the battery is fully charged, it will go to the load. If load is also fully charged, then the generated power is unutilized. Right. Imagine a scenario if there is no solar power, but still the battery needs to be charged or load needs to be obtained. In such case, the second priority auxiliary AC grid supply is given as an input. Okay. This time, this entire device will work as a normal home UPS. The system totally works as a normal home UPS. Right. Normally, the power will come. The inside circuit will convert the AC into DC, it will charge the battery, as well as the AC will get bypassed to the loads. Okay, so this is the working principle of an off-grid solar system. If you have any doubts in this, please clarify right now. If you are okay, then we'll go for the design of off-grid. If you are clear, then just text that it is clear. All right. So it's clear for Mr. Ashok Kumar. What about others? So Mr. Velmani also told you it's clear. So Ms. Kitika is also clear. So Mr. Kannan is also clear. Fine. So it's look like everyone is clear. So now we'll go for the design of system. So before going into the design, we must know the standards of solar PCU available. So if you look into that, the standard voltage of solar PCU is for 1 kVA, it is available in 12 volt, 24 volt. For 2 kVA, it is available in 36 volt, 48 volt. For 3 kVA, it is available in 48, 96. According to the requirement, see, it's not mandatory that it has to be like this. It depends on the manufacturer point of view. That's why I suggested you to take the data sheet of the product before going for any kind of matching. Okay. If you look in that sense, 1 kVA will include 1224. 2 kVA will include 3648. 3 will be 4896. Up to 5 kVA 96 will be there. And from 6 kVA onwards, 120 volt is there till 10. Okay. Right. What this voltage refers? If you are denoting 12 voltage, 12 volt, it means the PV also from the 12 volt configuration. The battery also should be in 12 volt configuration. And if you are connecting DC loads to the system, that should also be a 12 volt DC load. And if you are connecting any inverter, that should as an input of 12 volts bar 230 volt AC. Okay. This is what the representation of the system voltage. Okay. If the system voltage is deferred as this, then this is the base voltage for left side, right side, bottom side. That is the PV, battery, DC load, bar, inverter. Okay, right. Yeah. This is the basic understanding. Now, this is the load chart. This is the very important of working on the design of off-grid system. In an off-grid system, the main intention is to provide the backup. Okay, during power cut hours. Backup during power cut hours is the important aspect of an off-grid system. To understand the importance of off-grid system in its backup, what we need to do is we need to understand what are the loads available, how many loads, how many quantity of load is there, what is the total watts, then what is the backup power required. Okay. Now you see this is the total watts. Let's take this is A and quantity, that is the B. So if you see C is equal to A into B. Okay, so 40 watt bulb tube light, 5 numbers are there. If I put all the 5 numbers of 40 watt, then it will consume 200 watts of power. Okay, right. Then you just forget about this is the total consumption. You need to concentrate about this. This is the backup because this decides your battery backup. So this 200 watts has to be operated for 4 hours during power cut. So my D is, so if this is the D, then my E is C into D. Okay. So if you multiply 200 watts into 4 number, that will give the watt hour. So basically this is hard, this is watts. So if you multiply watt into hour, it will give watt hour. The watt hour is nothing but the energy. The energy is nothing but the backup energy required for the battery. So like that, you do the calculation for all the loads in your home or in your premises where you want to implement this design. Okay. If you do all this calculation, then whatever the total watts you are obtaining, this is your peak load. This is your peak load, which means if all the loads are operated at the same time, you will experience this much of power. Okay, that is the peak load. This peak load decides the inverter capacity. Coming to the next, after arriving the backup energy, all the energy, the total backup energy, this is the total backup energy. Right, the total backup energy. This decides the battery bank capacity. This decides the battery bank capacity. Okay. So from the battery bank, we will arrive the PV array capacity. So this is the approach of off-grid system. So first arrive the peak load to understand the inverter capacity, calculate the backup energy to understand the total backup energy to arrive the battery bank design. Then based on the battery capacity, arrive the PV array, because the PV array is really made into the picture in order to charge the battery bank completely during the daytime. Okay, so the design of PV array is completely dependent on what is the capacity of battery available inside. So are you clear with this? If you have any doubt with this particular page, please ask me right now. So please let me know if you are clear with this load chart part.
Hello, sir, your voice is not
You
clear.
clear? You can type it in the chat box. Yes, it's not clear. Is it audible now?
Yeah, now it's clear.
Yeah. Mr. Ashok Kumar, days of autonomy is equal to backup time. So days of autonomy is applicable for a street light applications. Okay. Or maybe if you apply in an off-grid system, how many days you want means basically you have to multiply the backup hours into that much of time. Okay. So in such case, instead of arriving, let's say in tube light, I put 4 hours. If you want autonomy of 2 days, then probably instead of 4 hours, you need to put it as 8 hours. Okay, any other doubts? Are you clear with this? Vijayalakshmi told no doubt clear, sir, and Ashok Kumar is also clear with this. And what about others? I'm expecting much more questions from the audience side. Okay, Mr. Kannan says it's clear. All right. Fine. So Velimani is telling to proceed. Okay, Velimani. Okay, Arbagam sir. So we'll proceed now. So you can just note it down two factors. One is the 882, that is a peak load, and 3198, that is the total battery backup energy. Okay, this is the two main factors. Based on that, we are going to start our design. Right. So now the peak load is 882. So with this, we are going to start the inverter sizing. Okay. So now the inverter selection, that is the first step A. So what is the first step A says is, you know that kilowatt is kVA into power factor. So this formula is a very common for, formula for all the engineering faculties. So whatever the 882 watts, what we are having is a load in terms of kilowatt. So we need to arrive the equivalent kVA for that. So we are considering 0.8 as a power factor here. So to arrive the kVA, what we need to do is we need to just divide the watts by power factor. So we're just calculating the 0.8 lakh as the standard worst case scenario. So if you calculate, it comes around 1.1 kVA. This is the actual capacity of the inverter supposed to be designed. But practically, you should not load 100%. You should load only 80% of the inverter by considering the future expansion of 5% as well as the thermal stability of the device of loading. So in that case, with 20% extra buffer, then probably you need to load only the 80%, which means if 1.1 is the 80% of its capacity, then what is the 100%? Okay. So if you divide by 80 into 100, so it will give you approximately 1.37 kVA. If you have any device 1.37 exact, you can use, or otherwise, what is the next highest rating, you can go for it. Okay. Since you know the inverter more than 1 kilowatt capacity is a 24 volt configuration, so our selection is going to be a 1.5 kVA 24 volt PCU. Okay, this is our conclusion of the inverter. So this is what the inverter we are choosing for this particular requirement. Okay, are you clear with this? So please let me know once this is clear, then we go for it. All right, so Arokira has told us clear, then Vijayalakshmi told Ashok. Yes. Okay, it's clear. So we'll go for the next. Next part is battery size. So in the battery size, the voltages cell wise, if you see, it is a 2 volt cell. There are 6 volt batteries, very rare battery. The most common available battery is 12 volt batteries. Okay. The 12 volt battery usually in the range in the market, you can see 24, 36, 45, 60, 75, 100, 120, 150, 180, 200 and 200, 220 AH. These are all ampere hours. Okay. So we are going to choose any one of this battery available in the market to suit our design. So that is the main thing. Now we are going for the battery bank calculation. This is the part B. Okay. Now we know the total battery backup energy required is 3198 watt hour. Okay. So the watt hour requirement 3198 watt hour is the energy supposed to be required at the AC load end. Okay. So it is very clear this is not the same energy as actually taken from the battery of DC, because battery is a DC, but load is an AC. Load point needs 3198. The point at which the socket is connected for the load, it needs 3198 whatever. But actually the power taken from the battery, DC power, will be more than the AC because there are conversion losses. Okay. So considering the DC to AC conversion losses with 80% of my inverter efficiency, I'm considering 80% as a worst case analysis. If you are having a 90% inverter efficiency, then probably the loss instead of 20%, it is going to be 10%. Okay. So I'm taking my worst case calculation. So 3198 divided by 80 into 100 if you put, this is my 100% of the energy, which probably I need to take from the battery to provide the backup for the entire load as designed. Okay. This is the first conclusion. Now, considering for a lead acid battery, the depth of discharge should not be more than 75%. Okay. The depth of discharge, which means out of 100% of the battery, you can discharge up to 75%, but still the 25% should also be rest as and residual power, residual energy inside a battery in order to maintain the healthiness of the battery. So I'm considering again 70% the worst case calculation here for my analysis. So I'm considering 70% of the DOD for a C10 battery. If that is the case, then this 3997.5 is the 70% capacity. Then I need to arrive my 100% capacity. So I'm just dividing by 70 into 100. I'm getting 5710 volt ampere hour. So this is my actual DC battery bank energy. Okay. If I'm having this much of energy inside my battery bank totally, I'm going to take 70% of it, and I'm going to lose 20% during my conversion loss. Then finally I will get this much of energy. Okay. If you calculate only for this, you will not get this. So depth of discharge is how much depth you can able to discharge the battery. Okay. Let's say you are having a 100 Ah battery, and you need 100 100 Ah equivalent of power to be delivered. So you should not choose 100 Ah battery for 100 Ah of requirement. What is the problem is you can only discharge 75%, which means you can probably discharge 75 Ah of power energy, but 25 is still left. So if you want to discharge 100, then probably you need to have more than 100. So that's why the 25% is left. Okay. So 100% is 75% into 100. So that much of power you should have, that much of AH you should have. So in this case, if you think you need an 100 AH of output, then if you divide 100 divided by 70 into 100, if you put, then you probably need 134 AH of battery in order to deliver 100 AH of power to the load. Okay, you should not use for 100, you should not use 100 AH battery. So that is what the DOD. Got it? So Ms. Vijayalakshmi got it? Yes. Okay. So this is how we are arriving the total battery bank capacity. Okay. Now we know that the system voltage is 24 volts. Now we are in the situation of sizing the battery and connecting the battery. Okay. So we know that this is the battery bank and 24 volts is the system voltage. Now how to size? If I divide this energy volt ampere hour by 24 volt, so volt will get cancelled. What you're getting is the ampere hour. Okay. If you divide, what I'm getting is 237.94 ampere hour at 24 volt configuration. But single battery is 12 volt. So if I can connect 237 AH of battery in series, my problem is solved. But unfortunately, we don't have a single 240 AH battery. The maximum battery available is 220 AH. So I am in a necessity to split this circuit into two networks. So what I'm doing is this, I am rounding off this 237 to 240 AH. This 240 is divided into 120 and 120 each. Okay. So now it become a two circuit. So how it has been done now is, so each is going to be a 12 volt 120 AH battery. All. So now you see 12 in series will give 24 volt. Again 12 in series will give 24 volt. Here, since it is a 120 AH battery, in series current remains same. It is going to be a 120 AH. Same here also 120 AH. But again I am paralleling here. Okay, again I am paralleling here. So because of the parallel, this 120 plus 120 will become 240 AH. Already my voltage is 24 volt. So I have literally achieved the 24 volt 240 Ah requirement. Okay. So this is how the battery has been designed. So you can see here in this presentation. So if you have any doubt with this, please ask me, right? Sorry, clear? All right. So Ms. Vijayalakshmi is clear. What about others? Sure, Ashok is also clear. Galvani sir is also clear. Yogaraj is also clear. Fine, very good. So now we have designed the inverter, we have designed the battery. Now we are going for the final step, that is the battery design. Okay. So in the battery design, panel design, that is a C, section C, last section we came. So the total battery bank energy is 5710 because ultimately this battery has to be fueled by the PV array during the daytime of 5.5 hours. Okay. Right. Now the calculation is consideration is sunshine hours. The PSH is calculated for 5.5 hours. The PV array capacity is, if you divide the total battery bank energy by 5.5 hour, it will give you the array capacity. So this is a normal requirement. But do you think a 100 watt panel will always give 100 watts, 100 watt as a practical output time? Temperature, dust, cable losses, all these things. So that's why I'm considering only the fill factor of 80%, which means I'm going to get only the 80% of the output, which means this should be the 80%. Then I need to identify my 100%. So that's why I'm dividing the 80 into 100. So I'm arriving 1297.5 watt peak is my total PV array capacity. This is my total PV array capacity. So to cross check the solar panel rating, what we need to do is we need to choose. Here I am choosing 330 watt panel. So what I need to do is I just need to divide this total PV array capacity with my single PV module wattage. So if you divide, then it's getting 4 numbers is required. Again, the system voltage is 24 volts. The voltage of a single 330 watt panel is also 24. In order to increase this power, the only option rest is you need to connect all the panels in parallel. Okay. So what you're seeing is the different panel sizes and its voltage. So panel watts more than 200 watts are coming under 24 volt configuration. Less than 200 watts are going for the 12 volt configuration. So now what we have chosen is 330 watt panel. So it is going to be a 24 volt configuration panel. Okay. So in this case, the layout will come like that. So you consider the 7 amps, 7 amps, 7 amps, 7 amps as an IMP. In this way, if you see, to arrive 24 volt configuration with a 330 watt panel, the only option is connecting 4 modules in parallel. Okay. If you connect all the panel in parallel, the voltage remains same. It's become 24 volt. All the power will add up. So 330 into 4 will become 1320 watt peak. And all the current will add up. So 7 4s are 28 amps will be the current of the particular network. Now, this is the final connection of the system. So you'll be connecting the 24 volt configuration PV array to the PCU. You will be connecting the 24 volt battery configuration to the PCU. And you'll be connecting a 230 volt single phase AC supply as an auxiliary input. And you will be connecting the AC load. That is a single phase 230 volt. So this is the off-grid system design. Sorry, clear? Do you have any doubts? If you have any doubts, please ask me. No. All right. So thank you very much. So this is all about the components, PV system design, which includes on-grid system design and off-grid system design. So now Mr. Ashok Kumar is asking if I'm running DC load, then how this approach will vary. So in this case, if you want to go for a DC load, so instead of using a single PCU, Some PCUs have a DC output also. Instead of using PCU, you can go for charge controller and inverter as a separate components. Okay, so you can take the output of DC from the charge controller. As because the PCU is combination of charge controller and inverter, so it is all integrated together in PCU. But you can do the system in the same two different ways also. You can have a charge controller and inverter, a separate component, and connect. All right, so thank you, and I would like to have a few more questions. So Mr. Ashok Kumar is asking, from your view, define MPPT controller and charge controller. So MPPT is maximum power point controller, and a normal is a PWM based controller. So the MPPT and PWM is mainly on terms of the efficiency part. MPPT is 25% efficient more than PWM method. And I would like to have feedback from the audience, so you can come and talk about, like, I think the people are running very fast from the 78 to 65. So I would like to have some kind of feedback from the audience, like how you enjoyed this program or how you feel bad about this program. So you can just unmute and talk.
Good evening, sir. This is Ashok Kumar from Madurai.
Yeah.
So, can you able to hear me, sir?
Yeah, I can able to hear you.
Yes, you have given a wonderful presentation. I have reviewed many of my basic concepts, and many of my fundamental understandings are also being cleared from your excellent presentation. The way you have interacted with the whiteboard as well as with the presentation content, it imagines me you are supposed to be an excellent teacher than us. So you are from industry, but you are making us to understand the concept very, very easier. So I am very happy to part of this presentation, sir. Very happy to hear
Thank
from
you very much.
you many more inputs, sir. Thank you so much for your wonderful presentation.
Thank you for your appreciation and your active presentation also. I have given my number and email ID, so you can contact anytime related to the subject. So definitely I'll extend my support towards that. And what about others? I would like to have a few more feedback, like how it was helpful for you. Anybody else would like to give feedback? Okay, feedback.
Sir, if you're done, I have a.
Yeah, tell me, who is that?
This is Sneha, sir, a team of ISC.
Yes, Sneha.
Yes, sir. Thank you for your presentation. If I'm not interrupting, I have an announcement to make. Yes. Thank you, everyone, for your presence and also your feedback. The feedback form for today's session has been shared by Mr. Kumanan in the WhatsApp group. Also, it will be sent through mail.
Yeah,
today.
it's already shared, Mrs. Sneha.
Yes, thank you, sir. About the agenda for tomorrow and the day after, which is day 2 and 3, will be shared shortly through mail, and the feedback forms will also be there. The link for Zoom meeting and YouTube meeting will also be the same. You can refer the same link that we sent out today for tomorrow's meeting. And your feedback and tomorrow and the day after will be assessed. The feedback and your assessment sheets will be sent out tomorrow after the sessions. So please kindly record your feedbacks for today's session. Thank you so much. Please continue, sir, with the questions and feedback.
Yeah, I'm done with my session, and I'm very happy to take the questions if anything is there.
Sir, good evening, sir. This is Dr. from KSR College of Technology, sir.
Yeah, good evening, sir.
Sir, am I audible, sir?
Yeah, you are audible.
Am I audible, sir? Sir,
Yeah,
I
you
have
are
only
audible.
one
I can
query,
hear
sir.
you.
Sir?
Yeah, tell me.
Yes, yes, sir. In your sessions, you told that in particular moment, you told that the CIG permission is required of, suppose we are installed more than 10 kilowatt. Then my question is, suppose we are not get the CIG permission, whether the EB permission can we got the EB permission, or it's a mandatory for getting the CIG permission, sir? CIG infrastructure.
If you are not getting and utilizing the plant, it is an electrical offense.
Oh. Okay, so that we have to concentrate on the earthing and then lightning arresters, everything as per the CIG norms. Even if suppose we are not able to get the permission, but we should get these things for
Safety
our
standards
safety
are not followed for CIG purpose. It is for our
Yeah.
own personal safety purpose. CIG is just validating it and saying yes, they are up to the mark. That's all.
Yes. So that EB also they are insisting that the customer to get the CIG permission before connecting
In the government mechanism, everybody has its own, the powers and limitation. If you look TANGEDCO, they are a DISCOM. Their work is to produce power and give the power to the consumer. That's all.
Yes.
Okay.
Yes, sir.
But they are
Okay.
not governing any law. They are not putting anything. That's where the TNERC comes into the picture. Correct.
Oh,
The
yeah,
TNRC
exactly,
comes
sir.
and Tamil Nadu Electricity Regulatory Commission gives the regulations. Okay.
Yes.
So based on
Okay,
the
sir.
regulations, the TNRC is recommending CIG to come into the picture. Their CIG work is to electrical inspect it. So they will come and inspect the plant of all the electrical related systems. It may be a DG, or it may be a power plant, it may be a thermal power plant or solar power plant. They will come and inspect. They will say this plant is up to the mark and safety. So we are certifying it is worth to, because we are not consuming only, we are integrating, we are injecting the power to the grid. That is the critical point.
Yeah, exactly. Okay, sir. I'll clear, sir. Thank you, sir.
Thank you.
Okay.
Any other doubts? All right, so Kumaran, I think there is no doubts from the audience side, and if you wish to conclude, you can conclude.
Yes, sir. Thank you very much, sir. Thank you for your wonderful presentation, sir.
Thank you.
So all other instructions are given by Ms. Sneha. So your feedback will be sent you shortly, sir, through email and WhatsApp.
Please send us feedback. I just want to have.
Participants are filling their feedback, so I will send you that feedback in email, sir.
No issues.
Oh, okay, sir. Okay, sir. So some participants are asking some materials. Can you please share any materials, sir?
I will share whatever the material I have displayed in this presentation. I will share to you. You share to all the people.
Fine, sir. Thank you so much, sir. So now, shall we leave, sir?
Yeah. Thank you very much. All the very best, and my best wishes for the academicians to train and groom the budding engineers. And I feel there is a strong commitment lies from your side. And since you are creating the next generation technocrats, my wishes for you, and also my encouragement for you to upbringing the next generation in a very better way and very strong way to work on the core concept, rather than looking for a job which will give a better salary than giving a job satisfaction. Thank you very much.
Thank you, sir. Thank you so much.
Thank you so much, sir.
Thank you.